So hello everyone, my name is Hallin. I work as an infrastructure engineer at Volvo Cars in Sweden. And I've been a Windows technician for almost 30 years, and I've worked with Ansible for the last 3 years. Today we will talk about how Volvo Car uses Ansible Automation on Microsoft Azure to accelerate time to automation. And in today's agenda, I will present how we use Ansible Automation as a managed application and why we migrated to an on-prem, to the managed one. Our onboarding process and how we have worked to speed up development, and the collections and the automations that we have used and the automations we have built. Some issues we have run into and some key results that we have achieved. And at the end, I will open up for a Q&A. So for the we started about 3 years ago with installing multiple environments of Ansible Tower. And for us, that led to a lot of issues to have them in sync and working. And we just spent a lot of time in trying to have the administration going, but it didn't work out. So we changed into the managed application running on Azure. And what we got with that was a platform with almost no administration. It is fully managed and regularly updated by Red Hat. It's always running and easy to scale when we need. And we have received excellent support from Red Hat support team. However, there are still a few administrative tasks that we need to perform, and that is around the execution environments. And by default, we got a few out-of-the-box execution environments configured, and they point to the latest images that Red Hat has published, so they are always up to date. But we use collections that also require additional Python packages to be installed, so we had to create our own execution environments, as these Python packages are not installed during Project Sync. But also around the user administration, as users that are in the system are not removed when they leave the company, so we have to work with that as well. So to automate the onboarding to the platform, we created a ServiceNow catalog so we can have people onboarded. And with this, a new team can be onboarded in minutes. Every team gets their own isolated organization to host their templates and projects. This means that each team can only see their configuration. And the key benefit with this is that we have got much faster delivery time. We have an automated SAML integration with the Azure AD security groups. And we have a unified naming convention for organizations and teams. And by using an Ansible playbook, we create an organization and an admin team that is linked to this organization. And then we set the role permissions to this admin team and the credentials to our private automation hub. And as the last step, we update the SAML team attribute mapping to pair the team with the Azure AD security group grid. And by that, users can now log in to the new organization using SAML authentication. And we have implemented a mandatory code review process to ensure that our code are following the Ansible guidelines. And through automation, we have been able to reduce the reviewers' work. The automation uses a GitHub action that triggers on all pull requests and runs the Ansible syntax check, Ansible lint, MD lint, and spell checking on selected file types. And to ensure that the developers can't bypass these code reviews, we created a branch protection rule on the staging and main branches. And we also enabled the require approval and require status checks to pass before merging. This ensures if the GitHub action reports that the status check failed, the pull request will be blocked. But if the automated code review is successful, a reviewer will be automatically added and assigned for manual review. And once approved, a new pull request to the main branch will be created automatically. We started an internal code sharing project, relatively new, and it was done this quarter actually. And by reusing code in shared roles and playbooks, we have got standardized processes and increased efficiency. When we have chosen a community-based development model, so anyone within the company can contribute to development of roles and playbook. And we create namespaces based on platforms, example Windows, RHEL, VMware, and Azure. And in these collections, we also have the names the same way. This to make it easier to identify the purpose of roles and playbooks. For example, the collection hosting_rel.azure contains roles that target RHEL servers in Azure. And hosting_windows.vmware targets Windows servers running on VMware. And the benefit of using in-house built roles and collections is that it makes it easier to read the main playbook as it contains much less code. It's easier to use that code as roles are just building blocks for a set of tasks. And if desired, these can be made public within the company by publishing them to our private automation hub. Each role in a collection is well documented and easy to access from the GitHub repository or from the private automation hub. And this means that the roles are maintained in one place and are version controlled. Any update to these roles will take effect on all playbooks, so there are no need to update on multiple places. And as seen on the screen, running an in-place upgrade on the Windows server and then patch it will be represented by only 11 rows in the main playbook. So as we all know, there are many tools and plugins for doing Ansible development. And what is right for you are up to you to decide. But with the right tools and plugins, you can work smarter and faster. And as an example, I have chosen to use VS Code with an Ubuntu VSL instance and a set of extensions. With this, I have been able to increase my development speed. And these extensions allow me to see any errors directly when the file is saved before it gets to our automated code review. And automatically, it gives suggestions on how to code just that specifically task. On the screen, you can see the list of some of the extensions that I have installed and how they can help me in my development. And as you can see, I get all the errors for the task right on the screen directly. So there's no need to wait to run the Ansible lint somewhere else or something like that. We think that development guidelines are very important. And already from the beginning, we created a strategy and a base for how we wanted our code, and we documented it in a docs folder in the repository. We documented down the naming conventions for variables, projects, templates, files, and so on. But also things that we require to be in a file. For example, the description section is required in the top of each playbook. And you can see how we do it on the screen here. And this has made it much easier to read and understand the code that someone else has written. And with the file and folder strategy, we know exactly what the playbook will target by looking at its location. And these are, of course, living documents and are constantly updated. The 8 listed collections to the right are the ones that has contributed to the success for Volvo Cars. And we started small 3 years ago with a few playbooks in automating server provisioning and server configuration. And we choose to provision out of the box default installation of servers and then run customizations with a configuration playbook on top of that. And we choose this model to make it easy to update the agent version and the OS images, as it allows us to use the same configuration for multiple OS versions. And when an agent is to be updated, it can be done by just replacing the installer in the installer storage account. And on the left side, you can see some of the automations that we have created: server provisioning, the baseline configuration, server patching, server start and stop, because we stop lower environments in Azure automatically out of office hours. Also, the full server decommissioning, end-to-end, fully automated. Also, the VM resize, both in Azure and VMware, have been fully automated. And even though we are very satisfied with the product, and it works very well for us, we did encounter some issues during the initial setup of the managed application. And we were, as I understood it, one of the first customers to install Ansible Automation Platform as a managed application running on Microsoft Azure. And what we saw was that our company Azure compliance policy created an extra layer of complexity, as it blocked the installer from working properly. And these compliance policies can also prevent Ansible Automation Platform to work properly. Among others, auto-scaling of the instance groups might fail. But also, a firewall opening from the internal network towards Red Hat's DNS servers were required to allow the automated certificate renewal. And we have also seen that some job executions might fail on Patch Tuesdays. 2 a.m., Red Hat will update the managed instance, and that can, in some scenarios, cause the job to fail. And we have also seen in some scenarios where job just ends with the error status. And this we have worked hard with Red Hat, with Red Hat support team to reduce, but we are not there yet. The key point for our success at Volvo Cars in using the Ansible Automation Platform as a managed application is that we have got less platform administration, and with the automated onboarding of new teams, they can be onboarded in minutes, right? Protected GitHub branches with automated code review ensures that Ansible code standards are being followed. And by using predefined code from our internal collections, we use standardized processes that help us speed up the development. Reduced delivery time for resources. Servers can be delivered in hours instead of weeks. Resource standardization. All resources are identical on delivery. But also, scheduled resizing of servers as well as server patching can be scheduled by the application owner at their preferred time. And at the end, not so unimportant, manual work for operations teams has been reduced. And those, my friends, what I would like to present today. So if you have any questions, please feel free to ask. Thank you. Yes? Tell you more about the community-based development. So basically what we did was that we created the collection and published them on the private automation hub, right? And then we have everything in GitHub. So we just encourage people to contribute to that. And we had a Teams, So we had a Teams channel created internally. And we just publish information there, what we are doing, how we are doing it, and that they should create their own collections and roles. So we had, from the beginning, we created the RHEL and Windows patching, for example. Then we had an operation team that created the Ubuntu and SUSE patching roles in the same way. So we just created a new collection for those. And that is the way it has been going. But obviously it started quite recent, so it's haven't got the momentum yet, right? Did it answer your question? Yes? Can you please, I can't hear you, sorry.
Gadgets are you using for your Windows endpoint automation? WinRM, PowerShell?
Yeah, so for the Windows automation, we use WinRM. So basically when we provision a machine, the only thing we do, we have this image, which is just allowing the admin password, and then open up for the WinRM in the firewall. That allows us, with the default password, go to the machine when it's provisioned, and then immediately we change the password. I'm not sure I understand the question. Whoa. I mean, yeah, obviously we have group policies that we apply as a part of the configuration process, obviously, yes. So when we install these Windows machines, I mean, we do everything from we format the extra drives, we patch it, we add it to the domain as it is created in the workgroup, right? And then we add all the group policies, security groups, and so on. And we also created roles for creating server access groups. So each server has its own server access group, so we can just add more groups into that. Yes?
Or if you could comment a bit on what you're doing in your onboarding pipeline, like where does it end? Is there any steps in the platform that are manual and anything like that was?
Could you just come from, because it's very hard and I can't go forward.
If you could speak on the onboarding pipeline and maybe some of the things you're doing in it, and any roadblocks you hit that were significant.
Okay, yeah, we can go back to the onboarding process here. So let's go back to that one. So what we did was that we had a request catalog created in ServiceNow. So basically what that does is just sending an API call, right? So the playbook is very simple. I mean, it's not even a workflow. So it just does exactly what I've stated up here on the screen. It creates the organization, because there is a module for it. So we just create the organization, we set the Galaxy credentials, and we create a team. And then we set the permissions to that team, to the organization. And then I would say the thing that is most crucial to do is update the SAML team attribute mapping, because doing that manually will be a mess. If you mess that file up, I mean, no one can log in.
One more question.
Yep.
Do they have to come with a repo, or do you have separate pipelines to like enable projects and templates? And
No, they get admin in their organization. So we create an admin team. If they want additional teams, they can create them separately. So we just set them up with an admin team, and then they are on their own. So if they want more projects to be created, I mean, we don't even create the project. So they need to do everything themselves. Because, I mean, we don't know where they have their code, right? If they have it in Azure or in GitHub or wherever they're going to be, right? Yeah, did you have a question? Oh? Okay. Thank you so much, and hope you enjoyed the time here.